Hello. So, hello everyone. How are you? I hope all of you are well, doing good. So, welcome. Yes. So, let's start today's session. That is your Queen theory. This lecture is your 6th number lecture. Right. So, here we are going to start some question on Queen theory. So, here is the question in front of you. Please read it out and solve this question. Here I am going to give you 5 minutes. Okay, so at least you will try this question. Sorry. Yes. Yes. Please try. Try this question. Yes, please try this question. What the question says, at least try 2 parts, right? Within a 5 minute, at least try 2 parts. Part number 1 and part number 2. At least try 2 parts. That is your part number 1 and part number 2. Yes. So 2 minute 53 second left. Yes. Are you solving this question? At least solve 2 parts, right? At least solve 2 parts, part 1 and part 2. So here your clock watch is running. 2 minute 18 second 15 second. If it is not visible, then see here, this is your clock which is running out. Yes, please. Yes, people. Yes, my dear. 1 minute 43 second. Yes. It's a good question. Every question is a good question. Every question has a potential, okay, that it will come into your gate exam, maybe this or upcoming, right? Maybe this or upcoming. So be serious and solve this question seriously. I will solve from my side, but at least you will try. But at least you will try. Yes. Let's see how many students are going to solve this question. Yes. So your time is going to be up, my dear. Your time is going to be up. 28, 27, 25, 24, 23, 22, 21, 20, 18, 17. Yes, my dear. You haven't given any answer. First part even first part is a very easy part. Even a first part is a very easy part. Yes. 5, 4, 3, 2, 1. Time is up. Right. Your time is up, my dear. Right. Your time is up. So let me solve this question. Right. Let me solve this question. I will try to solve this question. Okay, I will try to solve this question. On the telephone booth, average time, because I have to explain each and everything. On a telephone booth, average time between the arrival of one man and the next is what? 10 minutes, right? Next is what? 10 minutes. So in 10 minutes, there is one arrival. So I'm going to write each and everything here. I'm going to write each and everything here. I'm going to do the solution, right? So in 10 minutes, my dear, in 10 minutes, okay, in 10 minutes, there is one arrival. There is one arrival. Yes or no? There is one arrival, right? Now the next thing is that, and arrival are assumed to be poison. Arrival are assumed to be what? Poison distribution. Very good. Now the mean time of using the phone is what? 4 minutes. The mean time using the phone is 4 minutes, and it is assuming exponential distribution. Okay. Now before coming to this point, therefore, my dear, here, therefore, in 1 minute there are, in 1 minute, therefore in 1 minute, therefore in 1 minute there are how much? There are 1 by 10 arrival. How much? 1 by 10 arrival. So this is what? The arrival rate. There are what? 1 by 10 arrivals. So you can write it by lambda. Lambda equal to what? 1 by 10 arrival in 1 minute. Am I clear? Is that point is clear? In 1 minute, how many arrivals? This much arrival is there. Lambda is the arrival. Now service time is 4 minutes per arrival. Here service time is what? Service time, okay, here service time is 4 minutes per arrival. 4 minutes per arrival, right? Per arrival, right? Per arrival. Service time is 4 minutes per arrival. Service time in 4 minutes is per arrival. Therefore the service rate, therefore my dear, therefore service rate, therefore here, therefore the service rate, right? Therefore the service rate is what? Service rate, let's say I'm going to represent by mu. Service rate is what? 1 by 4. Okay, 1 by 4. 1 by 4 is the service rate, service per minute, my dear. Okay, service per minute, right? Service per minute. These are what? Arrival. These are what? Arrival per minute, right? These are what? Arrival per minute. Is that point is clear? Now he is asking the probability that one has to wait. He is asking what? He is asking the probability that a man will have to wait after he arrive. Suppose that a man is arrived and he has to wait. What is the probability for that? My dear, here P naught, let's say P naught, first part. Okay, first part. P naught, the probability that the arrival one has to wait, right? Here P naught basically the probability that the arrival has to wait. Okay, the probability, right? The probability, please see the question very carefully. I am solving very in a very systematic manner. The probability that one has to wait, the probability that one has to wait is what? 1 minus P naught. 1 minus what? 1 minus P naught. So how can we proceed further? The question is that how can we proceed further, right? So first of all, find out the P naught. First of all, find out the P naught. P naught is what? Here P naught is, okay, P naught is what? P naught is what? The probability. P naught, basically P naught equal to what? As you know, P naught is 1 minus, okay, you can also write the 1 minus lambda by mu. Yes or no? P naught equal to 1 minus lambda by mu, or you can write 1 minus lambda by mu equal to what? Q naught. Yes or no? Yes or no? Yes or no? So here, my dear, okay, 1 minus P naught, sorry, I have written this thing is wrong. Okay, the thing is that 1 minus P naught equal to lambda by mu, right? 1 minus, you can also write that P naught is what? P naught is what? 1 minus lambda by mu. So 1 minus P naught, here 1 minus P naught will be what? 1 minus P naught will be lambda by mu, and you have to find this. So lambda by mu is what? Here lambda is given, that is 0.1, and mu is given, that is 0.25. Am I clear? Am I clear? Yes, good morning to all, beta. Good morning to all. Good morning to all. Okay, now you are happy. I was busy in solving the question, right? So 0.1 divided by 0.15. So it will become how much? It will become 0.4. It will become 0.4, right? It will become 0.4, right? It will become 0.4, right? It will become 0.4. Let's say here P, the probability that one has to wait is what? 1 minus P naught. Am I clear? Is that first one is clear? P, I am assuming that P is the probability that one has to wait, that is 1 minus P naught. 1 minus P naught is what? Lambda by mu. Lambda is what? 0.1 by 0.25, and it will become 0.4. Okay, I hope this point is crystal clear. Now what he asking? Second part, the average length of waiting line from the average length of waiting time from time to time. On an average, you have to tell me the waiting line. So my dear, the average length of waiting line, or Q, listen me carefully, the average length of waiting line, or Q, okay, that from time to time, or average length of non-empty queue is given by what? Is given by the equation which I am going to write. Okay, is given by the equation which I am going to write. What I am going to say, the average length of waiting time. There are, you know, by three statement you can write down this thing. This is the average length now. Instead of that, examiner will ask. What examiner will ask? Examiner will say, okay, find out the average length of waiting line. Okay, the average length of waiting line, right? Or he will say what? He will say queue that from time to time, queue that from time to time, or average length of non-empty queue, average length of non-empty queue, non-empty queue, right? Non-empty queue, right? Non-empty queue. How can you find out? That is L average. That is L average. What is the formula? L average, okay, equal to lambda divided by mu minus lambda. Yes or no? Yes or no? So my dear, here lambda is given to us. That is what? Sorry, I have written the reverse formula. It will be mu. It will be mu divided by mu minus lambda. Mu divided by mu minus lambda. That formula was the weighting average, mean weighting average type. So here mu is what? Mu is given, that is 0.25, my dear, right? 0.25 minus 0.1 minus 0.1. How it will become? It will become 1.66%. 1.66%. Yes or no? Are you getting this point? So two part we have solved. Now you have understood. Now have you understood? Yes or no? Tell me. Yes or no? Tell me please. Now you understood? Yes or no? Tell me. Tell me. Yes or no? Now the two part is crystal clear. Now the third part is by how much the flow of arrival. By how much the flow of arrival, that is lambda dash. By how much the flow of arrival, that is what? Lambda dash should increases to justify the installation of second telephone booth. He wants to install a second telephone booth, and in that case he want to find out the flow of arrival. And here, assuming that second booth can be provided only when a person has to wait minimum for what? Minimum for 1 minute for the phone. Means if a person will wait for 1 minute for the phone, then what will be the arrival rate? Are you getting my point? So here, my dear, the thing is that you have to remember the mean waiting time of an arrival. Mean waiting time, third part, mean waiting time of an arrival, right? Mean waiting time of an arrival. Mean waiting time of an arrival. So the mean waiting time of an arrival is given by, let's say it is what? W average. Mean waiting time of an arrival, it will be lambda by mu. It will be lambda by mu into mu minus lambda. Am I clear? Into mu minus lambda, right? So here W average is given. That is what? That is the 4. Okay, this is 4 is given. Flow rate, okay, arrival flow we have to find out. Okay, service time is same, 0.25 into mu 0.25 minus lambda. Can we find out the value of lambda, please? Can we find out the value of lambda, please? Or can you tell me the value of lambda, please? Yes, can you tell me the value of lambda, please? Okay, if you are not, then I am going to solve, my dear, and it is comes out 4 into 0.25. okay, or okay, I am going to solve the value. If you are not going to solve, 4 into 0.25 minus lambda equal to what? Lambda. Okay, minus lambda equal to what? Lambda. So 4 into 0.25, answer into 0.25, it again 0.25, right? 0.25 minus 4 lambda equal to lambda. So 0.25 equal to what? 5 lambda. Lambda equal to what? Answer divide by answer divide by 5, it will become, answer divide by come, how much it will become? 0.05. Yes or no? Yes or no? Here it will become, am I doing right or wrong? Let me see. 0.25 into 4. Okay, answer into 0.25. Okay. I did one mistake. I did one calculation mistake. Yes. So here my dear, it will become 1 minus, it will become lambda. Okay, 4 into 0.5 is a 1, and lambda equal to what? Equal to, I think there will be some calculation mistake. Yeah, lambda. Okay, 1 equal to what? Lambda by 2 lambda. Sorry. Here lambda 1 equal to what? Yes, 2 lambda. Lambda is what? 1 by 2, and it is what? 0.5. It is what? 0.5, right? So my dear, 0.5 here arrival per minute. Okay, 0.5 arrival per minute. New arrival per minute are what? That is 0.5. Am I clear or not? Am I clear or not? Is that calculation is right? Please see. Is that calculation is right? Is there any doubt regarding this calculation? I don't think so. I don't think so. If any doubt, then please let me know. Right? 0, 4 into, yes, 1. Then 0.25. Yeah, it's 1. Yes. Tell me, my dear. Yes. Just a minute. It's a 1. 0.25 minus lambda equal to lambda. So 0.25 minus lambda equal to lambda. It's a 2 lambda. 0.25 lambda equal to 0.25 by what? By 2. My dear, 0.25 divided by what? Divide by 2. It will become, lambda will become 0.125. Yes, is that clear? So here lambda is what? The new arrival rate will be what? 0.125 per minute. Okay, arrivals per minute. These are the arrivals. These are the arrivals per minute, my dear. These are the arrival per minute. Is that clear? Is that clear? Now let's move to the next thing. Now what he is asking, assuming that second booth can be provided only when a person has to wait minimum for 4 minutes. Okay, now this is a new arrival rate. Now what we do, now what we have to do, my dear, thus the, here you can see, thus the flow of arrival must be increased from what? Increase from 0.1 minute to 0.125 per minute, right? From 0.125 per minute. Are you getting my thing? Here flow rate is going to be increased from what? 0.1. Initially your lambda is what? 0.1. Initially your lambda is what? 0.1. Now it is increases to what? 0.125 arrival per minute. Is am I clear? So this is the increment. This is the what? This is the increment, right? So this is the increment. Even if you want to know the second, if you want to know in the minute, in the hour, then you can also calculate. For an hour you can, sorry, here I'm going to wrong, right? Yeah, initially the lambda was what, my dear? Initially the arrival was 0.1 arrival. 0.1 arrival per minute. Am I clear? 0.1 arrival per minute. And now the arrival, let's say, is the lambda dash, 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 and lambda dash. Now here the arrival is what? 0.125 arrival, right? Arrival per minute, right? If you want to see number of arrival in number of hour, then what to do? Convert in number of hour. My dear, 0.1 into what? 60 arrival. 60 arrival per hour. So it will become how much? 6 arrival. Initially 6 arrival per hour. Initially 6 arrival per hour are coming. Initially 6 arrival per hour are coming, and here the lambda dash is what? That is 0.125 into 60 arrival per hour is coming. Now can you find out the percentage change? Okay, so 0.125 into what? 60, 7.5 arrivals. So here 7.5 arrivals per hour. Now can you find the percentage increase? Now suppose examiner will ask this thing in a different way. How much percentage increase in arrival? If he asks how much percentage increases in arrival, how much percentage increases in arrival, then how can you find? The percentage increase is, that is what? Your lambda dash minus lambda divided by lambda into what? 100. So lambda dash is what? 7.5 minus 6 divided by 6 into what? Into 100. Am I clear? So the percentage increase is what? 7.5 minus 6, answer divided by 6, answer into 100. My dear, 25%. So 25% increment is there. Is that clear? Tell me, is that clear? This question is a very good question. Is that question is clear? In one question I have covered 4 questions. In a one question I have covered 4 questions. Yes or no? So within a 26 minute you have solved 4 questions. So this type of question, whether he asks in MSQ or in MCQ also. In MSQ he can solve, he want to solve you all the part, but in MSQ you have to solve only one part. Is that point is clear, my dear? Tell me yes or no. Arey Baba, tell me na, yes or no. Is that clear? Yes. Is that clear? Okay, let's move to the next part. Next question. Yes, please solve. Yes, please solve. I think 5 minutes is sufficient. Yes. Yes, please. Please solve the question. Yes, my dear student, please solve. Yes. Yes. So worker comes to tool store. Worker comes to tool store room to inquire about a special tools. Inquire about special tools for accomplishing a particular project assigned to them. A particular project assigned to them. The average time between two arrival is 60 seconds. The average time between the arrival is what? 60 seconds, right? This is the average time arrival. Clear? So here, this is what? This is the average time arrival. Now, the average time arrival is 60 seconds and the arrival are assumed to be Poisson distribution. And the arrival are assumed to be Poisson distribution. Okay. The average service time in 40 seconds. The average service time is 40 seconds. Determine the average queue length, average length of non-empty queue, average number of worker in a system. Okay. System, average number of worker in the system including the starting, I think starting one also, mean waiting time of arrival. So, have you solved the two parts? Because this 2 or 3 parts are straightforward. They are what? They are the formula based. They are the formula based. Directly put the formula, you can get your answer. Directly put the formula, you can get your answer. Yes, please. Yes. Yes. So tell me, after 15 seconds I am going to start the discussion. Okay, see here. I hope you have noted down the data. Now I am going to solve the question. See, solution. Are you people waiting for the solution? Because today you are not giving any answer. So I think today, today you people are waiting for the answer. Okay, just wait for the 5 minutes. Once the 5 minutes are going to be over, sir will tell the answer. This is not the right attitude, right? Here I am giving you the time now, just like I am providing you the exam atmosphere, right? So my dear, here you have to find out the arrival rate, that is lambda. Lambda is what? The arrival rate, and 1 by 60 arrival per second, right? 1 by 60 arrivals per second. Okay, these are the number of arrivals per second. Or here, if you want the number of arrival per minute, then arrival per minute are what? 60 by 60 arrivals per minute also. So it will become one arrival. It will become one arrival per minute. One arrival per minute. One arrival per minute. Am I clear? Now, mu, that is a service rate. Service rate is what? That is mu 1 by 40. Okay, 1 by 40 service per second. 1 by 40 service per second. So for a minute, or you can write 60 by 40 service for a minute. So it will become how much? 1.5 service. 1.5 service per minute, right? 1.5 service per minute. Clear? So average queue length. Here average, first average queue length, average queue length, right? Average queue length. Let's say it's LQ, average queue length will be what? Will be your lambda square divide by mu minus lambda, mu into mu minus lambda. So here it will become 1.5 minus 1. So you will get how much? Average queue length, that is 1.33 worker in line. 1.33 worker in a line. So this is what? This is the first part, right? This is what? This is the first part. Second, you have to find what? You have to find the average length of non-empty queue. You have to find average length of non-empty queue. So my dear, average length of non-empty queue. Okay, average length of non-empty queues will be what? Average length of non-empty queues. Okay, so average length of non-empty queue will be, let's say, okay, it will be L average, and it will be what? It will be mu divided by mu minus lambda. Mu divided by mu minus lambda, and mu will be 1.5 divided by 1.5 minus 1. So it will become 0. It will become 3 worker, right? 3 workers always there in a non-empty queue. Average length of non-empty queue, right? Straightforward na. Now third, that is a C part. I think it's a part wise na. It's a part wise. So let me write down. It's a A part. It's a A part. It's a B part. Now it's a C part. So now he is asking average number of worker in the system. He is asking average number of worker, average number of workers in the system, workers in the system, my dear. What? In the system, including the worker being served, including the worker being served, the worker being, okay, served, the worker being served, the worker being served. So what is that? What is that? That is, let's say L, right? Let's say L. I generally represent by LS, that is a system. Okay, system length. So it will be what? It will be average number of worker in the system, including the worker being served. It will be what? That is lambda divided by mu minus lambda. Lambda divided by mu minus lambda, and here lambda is what? 1. Mu is what? 1.5 minus 1. So how much it will become? 2 worker. How much it will become? 2 worker. How much it will become? 2 worker. Yes or no? Is that clear? Now he want to know the fourth part, that is mean waiting time of an arrival. He wants to know the D part, mean waiting time of an arrival. Mean waiting time of an arrival. So what will be the mean waiting time of arrival? It will be, let's say, the mean waiting time of arrival is lambda. The mean waiting time of an arrival, that is lambda by mu into mu minus what? Lambda into mu minus what? Lambda. So it will be, my dear, 1.5. Just a minute. Lambda is what? mean waiting time of an arrival, right? Mean waiting time of an arrival, yes. So it will be 1 mean waiting time of an arrival, yes. 1 mu is what? 1.5, 1.5 minus 1. So let me calculate what it will become. Mean waiting time for an arrival. So it will become 1.5 into 0.5, 1 divided by answer, it will become 1.33 worker per minute. So it will become 1.33 workers per minute. Okay, 1.33 workers per minute. Is that clear? Now the next part, what he want, mean waiting time of an worker. Okay, mean waiting time of an worker. Oh my god, the question is too lengthy. In the same question you have to find the E part also. So what is the E part? E, the average waiting time of an arrival who waits. You have to find the average waiting time of an arrival who has to wait. So the average waiting time for the worker who waits, that is your, please see, that is what? The average waiting time for an arrival, average waiting time for the worker who wait. Average waiting time of an arrival who wait. So this will be 1 divided by mu minus lambda. Okay, this is 1 divided by mu minus lambda. So 1 mu is what? 1.5 minus lambda. Okay, 1.5 minus lambda. So it will become 2 worker. It will become 2 minute waiting time. 2 minute waiting time. 2 minute waiting time. Is that clear? 2 minute waiting time. Very good. Now the next thing is that what he asking, the F part, little bit lengthy. F part is little bit lengthy. So what we have to do? Now tell me what we have to do for the 10th part, for the F part. My dear, he say the type of policy to be stabilized. Okay, we are going to stabilize a new policy. We are going to stabilize what? Stabilize a new policy. In other word, determine the additional number of tool store room. Determine the additional number of tool store room attendance, which will minimize the combined cost of attendance. Ideal time, which will minimize the combined cost of attendance ideal time and the cost of worker waiting time. You have to minimize this. Right? You have to minimize this. Assume the charge of a skilled worker. Is 4 rupees per hour. Assume the charge of a skilled worker is rupees 4 per hour. Right? Is rupees 4 per hour. Is that clear? Is rupees 4 per hour. Right? And that of tool store room attendance, is what? Tool store room attendance, this much. So this cost you have to what, my dear, have to minimize. Right? For that you have to find out the ideal time. First of all, for that you have to find out the ideal time. So what is the ideal time? Find out the probability. Right? Find out the probability. So ideal time, for that you have to find the probability. That's, let's say, P naught is the probability of ideal time, and it will be 1 minus what? Lambda by mu. It will be what? 1 minus lambda by mu. So 1 minus lambda is 1, mu is 1.5. So how much it will become? It will become 0.333. Right? It will become 0.333 or 33.3% of ideal time. Okay, 33.3 ideal time. 33.3% ideal time. Am I clear? Am I clear? Yes or no? Now, if there are 8 working hour a day, let me see how many working hour in a day. Is that given? Worker comes to the tool room, okay, accomplish a particular project, assign the arrival 60, the average, determine, okay. Now, let me see the question, the type, in the other word, determine additional cost of a storeroom, okay, attendance, idle time, the cost of working waiting time, assume charge of a skill is 4 rupees per hour and the tool of is per hour. I think some data is missing. So here I am going to be mentioned, don't worry. Here we have to mention the number of, basically what? The number of working hour. The number of working hour data is missing. Okay, the number of working hour data is what? Missing here. So just a minute, I am going to meanwhile you can solve the question. Meanwhile you can solve the question, please. Meanwhile you can solve the question. Okay, yes, data was missed. Data was missed. Assume that 8 working hour. Assume that 8 working hour. 8 working hour. Right? That data was what? That data was missed. Now, this is a probability of ideal time. Now, if there are 8 working hour a day, the cost of ideal for one attendance is what? The cost of ideal for one attendance is what? Assume, okay, I have given you there is a 8 working hour. Okay, I have given you there is a 8 working hour. If there are 8 working hours a day, if there are 8 working hours a day, right? If there is 8 working hours a day, the cost of ideal time, the cost of ideal time, the cost of ideal time for one attendant, how can you find? Now, there is the number of working hours are what? 8. There will be a 8 working hour. Now, how much percentage of ideal time? 33.3%, means 0.333. So 8 into 0.33, that much is the ideal time. Okay, now you are paying how much cost? 0.75. So 0.75 rupees you are paying. So the cost of ideal time for one attendant will be, that is your 8 into 0.33 into 0.75. It will become nearby 2. It will become nearby rupees 2 per day. Okay, 2 per day, because there is a 8 working per, okay, 8 hour working a day. Now, worker in 8 hour will arrive as many as workers in 8 hour will arrive as many as how much? 480 times. Workers, or the arrival in 8 hour, the arrival will become for how much times? Are you getting this point? So this is what? This is rupees 2. This is rupees 2 per day, right? This is rupees 2 per day. So now you have minimized the, now this is the cost, right? This is the cost. Now, my dear, worker in 8 hour will arrive as many as how much? 60 into 8, right? Because arrival rate is what? 60. So 60 into 8, that is 480 times, and the cost of waiting time will be, that is 480. Okay, 480 waiting time, 480. Let me write down cost of, okay, 480, because 8 into 60. So number of arrival are what? 480 arrivals, 480 arrivals or 480 times, and the cost of waiting time will, and cost of waiting time, cost of waiting time will be what? Cost of waiting time will be 480, right, into 480 into what? 480 into your average queue length. Okay, 480 into your average queue length divided by what? Number of arrival, that is 60. 480 number of arrival, that is 60, into what? That is the 4. Because in the question it is given, that is rupees 4 per hour. Okay, the cost of working waiting time, that is rupees 4 per hour. So this will be the, so how much it will become? It will become 481.33 divided by 60 into 4. How much it will become, my dear? My dear, it will become nearby 42.56 per day. Rupees 42.56 per day. Is that clear? Is that clear? Okay, so let's move to the next question. Yes. So your time starts now for this question. (4 minutes 50 seconds). Your clock is running. You can see this is your clock which is running. B&K grocery operation operates with 3 checkouts counter. There is a grocery there is a grocery, okay, which operates with 3 checkout counters. The manager uses the following schedule to determine the number of counters in operation. Depending on the number of customer in a store 1 to 3, the number of counter in operation is 1. When number of customer are 4 to 6, then number of counter in operation 2. If number of customer are more than 6, then number of counter are what? Oh my god, the number of counter is 3. So customer arrive in the counter area according to the Poisson distribution. Here customer arrive in the counter area according to the Poisson distribution with a mean flow rate of 10 customer per hour. With a mean flow rate of a 10 customer per hour. So lambda is given, 1 by lambda is given. Okay, the average checkout time per customer is exponential with mean 12 per minute, right? So 60 divided by 10, 6 customer, basically 6 customer per hour are coming. 6 minute per 6 customer per minute are coming, and okay, 12 minutes. Determine the steady state probability Pn. Determine the steady state probability Pn and n customer in the, here at the last, customer in the checkout area. It is written that checkout area, checkout. Okay, it is written that here checkout. Yes, it is written checkout area. Here in the last you can see it is a checkout area, right? Checkout area. Now, so I have read the question and little bit I have explained also. So can you please try this question by your own? Can you please try this question your own? Can you please try this question by your own? Yes. Yes. n are the customers, and let's say the number of customer may be 1, right? The number of customer may be 2, or the number of customer may be 3, or you can find out the mu according to Pn, or according to n you can find out the mu n also. Customer arriving in the counter, customer arriving in the counter area according to the Poisson distribution. Okay, according to what? According to the Poisson distribution, right? According to the Poisson distribution, right? According to the Poisson distribution. Okay, according to the Poisson distribution. Now listen me. Here what you are seeing, customer arrive in the counter area according to a Poisson distribution with a mean rate of 10 customer per hour. With a mean rate of 10 customer per hour, the average checkout time per customer is exponential with. In the question it is given the average checkout time per customer is exponential with mean of what? 12 minute. Mean of what? 12 minute. Okay, time is up. Now time is up. Okay, per minute. Now determine the steady state probability Pn of n customer. We have to find out what? Determine the steady state probability. We have to find out, determine the steady state probability Pn. Determine the steady state probability Pn, right? Pn of n customer, of n customer, of n customer, right? Of n customer, of n customer in the checkout area, in the checkout area. Okay, from the information of the probability we have the lambda n, right? Or the number of customer, those who are coming, right? The number of customer, those who are coming. So let me solve this thing here. Yes, let me solve this thing here. Here please see, where number of customer which are arriving, that is lambda n, or you can say a lambda is what? That is the arrival. 10 customer per hour, my dear. 10 customer per hour, right? 10 customer per hour, right? Per hour. Now for mu n, now this is given that 12 arrival rate is what? 12 minute, right? 12 minute. Now I am going to find out what? How many customer are coming per hour? How many customer are coming per hour? Sorry, how many customer are getting the service per hour? So it will be what? When n it will be what? It will be 60 divided by what? 12. Okay, customer per hour getting the service. If the number of counter is 1, if the number of counter is what? 1, right? Let's say if the number of counter is 2, how much it is coming? It is coming customer per hour. It is coming 5 customer, right? 5 customer per 5 customer per hour, right? 5 customer per hour. Now 5 customer per hour. So number of customer in store. Okay, they are getting relief now. They are getting relief. Now when there is a one counter, there is a 5 customer per hour are relieving. When let's say n equal to 2, okay, let's say when n equal to 2, then the 2 into 5 customer, 2 into 5 customer, 2 into 5 customer per hour. So it will become 10 customer per hour, right? 10 customer per hour. Let's say when n equal to let's say when number of counter will be what? 3. So here 3 into 5 customer are getting a service per hour, right? Are getting a service per hour. So this is a mu n, this is a mu n. So these are the customer which are getting the service from their various counter, right? From the various counter, my dear. So I hope this point is clear. Now the probability P1, okay, for one customer, right? Now the probability for P1, I am going to find out the P1, probability of P1. My dear, here I am going to find out the probability. Please pay attention. Please pay attention here. Please pay attention, right? Please pay attention here. Now here you can see that, the P1 is what? Basically P1 is basically your 10 by 5, that is your 10 by 5 lambda by mu, right? Lambda by mu, okay, lambda by mu into P naught, lambda by into mu into P naught. So it will be what? 10 by 5. So 10 by 5, that is 2 P naught. Okay, P2 for 2 customer. Okay, P2 for 2 customer. So it will be what? The probability, that is lambda by mu, okay, square P naught. So it will become 4 P naught. Am I clear? When P4, so on for P3, P4, P5, P6 up to P7, let's say, right? Up to P7, let's say, if I'm going to take. So similarly, P3, P4, P5, P6, because he is talking about up to the customer of 6 or more than 7, I mean more than 6, that let's say 7. Let's say 7 is the boundary condition. Let's say 7 is the boundary condition. So my dear, this will become lambda, this will become again 2. Again it will become 2 to the power 3 P naught. So it will be 8 P naught, right? This P4, that is 2 to the power what? 4. Okay, just a minute, lambda by, yes. Here the twist is going to become, my dear, here P4, the twist is going to become, here lambda, here you are going to increasing the customer more than 4. So the probability will become 10 by 5, okay, here 10 by 5 to the power 3 into 10 by what? 10 by 10 into P naught. 10 by 10 into what? P naught. So it will be what? It will be again 8 times of P naught. It will be again 8 times of what? P naught. Now if you are talking about the P5, then it comes 10 by 3, it comes 10 by 5, okay, 10 by 5 to the power 3, to the power 3 into 10 by 10 to the power what? To the power 2, right? To the power 2 into P naught, to the power 2 into P naught. It will become again 8 times of what? P naught. My dear, continuously it will become 8 to the power P naught up to P6, right? For P6 it's also come what? 8 times of what? P naught. 8 times of what? P naught. For 7th and so on, right? For 7th it will become same, right? It will become same, right? It will become same. So the thing is there, we have to basically find out the probability. The value of P naught is determined by which equation? The value of P naught is what? As you know, we can find the value of P naught. We can find the value of P naught, that is what? P naught plus P1 plus P2 plus P3 plus P4 plus P5 plus P6 plus P7 equal to what? The sum of all probability equal to comes what? Comes 1. So here this is what? This is the P naught. Now you know the value of P1. P1 is what? P1 is the 2 times of P naught, right? So P naught will be comes out, so 2, and it will be 4, and it will be the 8, right? P4, P3 is 8, P4 is also 8, P5 is also 8, and even P6 is also, are you getting my point? Even P6 is also 8, right? P6 is also 8. So P6 is also 8. So it will be go. Further it will be equal to what? 1, right? Further it will be going to what? 1. Now what you do? You have to use a geometric series here, right? You have to using a geometric series. Because here time is less, so I have to solve another question. So I am giving you a hint. Using the geometric sum series, using the geometric sum series, you have to use the geometric sum series, and you have to solve this thing, right? You have to solve this thing. And while using the geometric sum series, you know the geometric sum series. Geometric sum series is what? Summation I to infinity, right? Summation I to infinity 1 by 1 minus x, okay, which is less than equal to what? 1. So here we are assuming that probability is not greater than when it is less than equal to what? 1. We are assuming that probability is not greater than when the cumulative sum of all the probability will be equal to 1 or less than what? Less than 1. So using the geometry series, you can solve this thing, right? You can solve this thing. Am I clear? So here I'm not going to waste, here I'm going to invest the time on the next question. Please solve the next question, or otherwise I am going to solve the next question. Instead of that, you solve this question. Just a minute. Yes, let's solve some line balancing question. Solve this line balancing question. Solve this line balancing question. Right? Solve this line balancing question. Yes. Yes, everybody. Please solve the question of line balancing. There is assembly of an equipment involved. Involves the task A to N. The precedence task and the processing time of these activity in minute are given in the following table. Considering cycle time of 20 minutes at any workstation, balance the assembly line and find the number of workstation. Also find the idle time at each workstation. Yes. Yes, please. Solve this. Yes. So the cycle time is what? 20 minutes at any workstation, right? So balance the assembly line. So for what we do? First of all, we have to draw the network. My dear, in one question, you will get all the concept of what? All the concept of your line balancing. When you are going to solve this question, you will get all the concept of your line balancing. All the concept of your line balancing. Yes. Sorry. Yes. So first of all, at least draw the network now. At the end, LM is written. This is L and this is M. LM. So at least please draw the network. If you are not able to draw the network, then do one thing. At least note down this table, so that when I can draw the network, now you can refer this value. Please note down this table also, yaar. If you are not able to draw the network, then it's my humble request, then please note down this table. Please note down this table. My dear, please note down this table. Have you noted this table? Have you noted this table? Yes or no? Have you noted this table? My dear, have you noted this table? Arey, tell me, Baba, have you noted or not? Have you noted this table? At least please note down this table so that I can solve the question, so that I can draw the network first. Okay. You have noted. Okay. Now, first of all, my dear, draw the network. So for that, I am going to draw the network here. Please see. Okay. For that, I am going to draw the network. Here, please see. What he says ABC has no precedence. So it means ABC are the starting activity. A, B and C. A, B and C. Right. Then what he say? D, E, F has a precedence of A, B, C. D, E, F. So here it will become D, E and what? F. Right. D, E and what? F. Clear? D, E, F. Right. Okay. They are going to close this. They are going to end this event. Let's say they are going to end this event. Now, what he say? He say that okay, D, E, F. Now G is a G has a precedence activity of what? D. Okay, D. Write down here G. This is activity G. This is activity what? G. Clear? Now next, H has a precedence of what? E, and E is a precedence of what? B. So here H has a precedence of E. So my dear, H, let's say this is H, right? H, and I has a precedence of what? F. But here F is there. Yes, F has a precedence of C. Okay. So I is there. I has a precedence of what? F. So this is, let's say, what? Activity I, right? This is activity what? This is activity I, right? Now let's see what he is saying. He is saying that it is clear. Now J has a precedence activity of what? J has a precedence activity of what? G. Okay, J has a precedence activity of what? G. So let me draw here. J. Okay, J. So this is what? This is, let's say, J, right? This is J. Now what he say? He say K has a precedence activity of what? I. Okay, so here K, I am drawing here K. Please see here, I am drawing K. This is activity K. Now L has a precedence of J and H. J and H. Okay, so this is J and H. So this is J and H. This is H. Okay, and L has a precedence of J and H. So this is what, my dear? This is, let's say, L, right? This is activity, let's say, what? L. Clear? Now what he say, that M has a precedence of what? K. Okay, M has a precedence of what? K. So let's say this is activity what? M, right? Then he says N has a precedence of what? LM. So this is what? L, and this is what? Let's say this is what? L. Oh, sorry. Yes, this is what? LM. Okay, and the last activity is what? Your N. Your N. So this is what? This is the N. Am I clear? Am I clear? Now write down all the processing time. Processing time of A is what? Processing time of A is 6, right? Processing time of B is what? 5. Processing time of C is what? 4. Processing time of E is what? 5. Okay, 5. Processing time of D is what? That is 8. Processing time of F is what? Processing time of F is what? That is 4. Processing time of G is what? That is 7, right? That is 7. Processing time of H is what? That is 6. Processing time of I is what? That is 10. Processing time of K is what? That is 7. Please see the table. Processing time of G is over J is 10, right? J is what? 10. Processing time of M is 6, right? And processing time of L is what? That is 10, right? That is 10. Processing time of N is what? That is 9, right? That is 9. So my dear, according to the rank position method, you have to find out the weightage. According to the rank position method, you have to find out the weightage. So my dear, here I am going to draw a table of the weightage. Here I am going to draw the table of what? Table of weightage, right? This is the weightage table. So here I am going to write the weightage. Here I am going to write the weightage, right? Weightage, W-E-I-G-H-T. Okay, here I am going to write the weight. So what is the weight of A? Weightage of A. And weightage of A, basically you have to start from A and you have to end to the activity end through longest path. Through longest path. So my dear, 6 plus 8 plus 7 plus 10 plus 10 plus 9, how much it will become? How much it will become? It will be 50, my dear. It will be 50. Am I clear? It will be 50. Now find out the weightage of B in a similar way. Start from B and end to the activity end through longest path. So this is the only one path. Okay, 5 plus 5 10 16 16 plus 10 26 26 plus 9 35. So it will become 35. It will become 35. Now find out the weightage of C. Find out the weightage of C. Start from activity C, end to the end through longest path, and only one path is there. 4 plus 4 8 18 18 plus 7 plus 6 plus 9. How much it will become? 40. So it will be my dear, how much? 40. Now similarly for activity D. Activity D you can find out from where? Start from D and end to and you have to end at the end through longest part. So 8 plus 7 plus 10 plus 10 9. 29 plus 8 plus 7, that is 17, and it will become 44, right? It will become 44, my dear. It will become 44. Are you understand? Do you understand how can you calculate the weightage? Tell me yes or no. Do you understand how can you calculate the weightage? Let me know, yaar. Do you understand how to calculate the weightage? Yes or no? Do you understand how to calculate the weightage? If you understand that, similarly you have to write down the weightage or weight of all the activity. So for activity E, the weightage is what? The weightage is 30. Please see your network. Okay, for the activity F, the weightage is what? 36. Okay, for activity G, the weightage is what? 36. Again, the weightage of H is what? Weightage is 25. Right. For activity I, the weightage is what? 32. Right, 32. For activity J, the weightage is what? 29. Right. For activity K, the weightage is what? 22. Right, for 22. The activity okay, K, let me see, K is what? K is 22. Right. For activity L, the weightage is what? 19. The weightage is what? 19. For activity M, the weightage is what? 15. Right. For activity N, the weightage is what? 9. So these are the weightage of the activity according to the network. These are the weightage, okay, according to the activity of network. Now my dear, according to the weightage, you have to arrange all the activities. According to the weightage, you have to arrange all the activity in the increasing order. Those activity which have a high weights, they have to put at the topmost position, and you have to arrange in the decreasing order. Right? You have to arrange all the activity in the decreasing order according to their weightage. Are you getting my point? So here I am going to arrange the activity. Here I am going to arrange all the activity, okay, in the decreasing order of their weightage. In the decreasing order of their weightage. Am I clear? So here I am going to write down. Okay, here I am going to write down the weightage. So my dear, which activity has the highest weightage? Tell me from your table, which activity has the highest weightage? Which activity has the highest weightage? I think A has a 50. Which activity has the highest weightage? That is what? A. See here, the highest weightage is what? A. So A is going to be what? A is going to be selected. Okay. Now the next activity is what? 35. Okay, 40, 44. The next activity is what? D. D has the highest weightage. So write down here what? D. Write down here what? D, my dear. Now the next weightage is what? After D, that is what? C. So C has a weightage of what? 40. So write down C here. Write down C here. The next weightage is what? After C, 40, 40, 40, 40, 40. The next weightage is what? F and G. Both are 36, 36. You can write both the activity, that is F and G. That is F and G. Right? F, G. This is what? F, and this is what? G. Right? This is what? F and G. F and G. Or even you can write GF. Right? Even you can write the GF also. It doesn't matter if the weightage are going to be coincide, if the weightage are going to be tie, if the weightage are going to be tie, then the question is, sir, which activity we have to place? Any activity which you want, it's up to you. Okay, FG, or you can write GF. It doesn't matter, my dear. It doesn't matter. So here GF, right? Here GF. After that, I think GF and G is clear. I think B, that is 35. That is B. Okay, that is 35. After B, which will be the activity? I think it will be, B is finished. I think it will be I. That is 32. That is 32. So here the activity is what? 32 activity, that is I. I is over. After 32, which activity has the highest weightage? E. What do you say? After I, it will be E. So E is going to be over. Here E. Right? Here E. Now after E, 30, 30, 30, then 29. That is what? Activity J. That is what? Activity J. Yes or no? Activity J. Are you getting my point? After J, let me see. Okay, 29. Okay. After J, let me see which activity. I think it will be H. That is 25. That is 25. That is 25. After H, the activity will be what? I think K, 22. I think K, it will be 22. Okay. After K, the activity will be what? the activity will be what? C. Which activity? That is L, and then after M, and at the end N, LMN. So here I am going to write L, M, and at the end it will be N. Now we have arranged the activity according to their weightage, or we have given the rank. We have given the rank to all the activities. We have given the rank to all the activities which have their which have their respective weightage. Those activities which have a high weightage, they come at the higher place. Right? Now my dear, what to do here? Now my dear, here I am going to take a copy of this slide. Okay. Now see here. Now here I am going to rub first of all this thing. I am going to rub this thing. I am going to rub this thing. I am going to rub this thing. Now the next step in line balancing, my dear, you have to divide the station. Basically you have to arrange the activity. You have to arrange the activity. Okay. Write down the activity duration. Write down the activity duration, because it is required for your convenience. It is required. The duration of activity A is what? 6. Yes or no? The duration of activity D is what? 8. Right? The duration of activity C. The duration of activity C is what? 4. Okay. Please write down the activity duration. It is very, very important. It is very, very important. Right? The duration of activity G is what? That is 7. The duration of activity F, that is what? That is 4. The duration of activity B, that is what? 5. The duration of activity I is what? The duration of activity I, that is what? 10. The duration of activity E, that is what? 5. The duration of activity J, okay, the duration of activity J, that is what? 10. The duration of activity H, the duration of activity H, that is what? 6. The duration of activity K, the duration of activity K, that is what? 7. The duration of activity L, how much? That is 10. The duration of activity M, that is what? 6, I think. Please see, it will be a 6 or not. Let me see whether it is coming 6 or not. Yes. The duration of activity N will be what? 9. Now, my dear, you know that in the question, cycle time is what? 20 minutes. Means every station cannot take. Station is what? A group of activity. Station is what? A group of activity. So a station cannot take a time more than 20 minutes. So you have to group now the next step is that you have to group the activity in such a manner so that they are not going to take more than 20 minutes. Right? More than 20 minutes. So here please see, I am going to group the activity. Here I am going to do a grouping of the activity so that they make a station. My dear, here please see. Here 6 plus 8 plus 4, it will be 18. If you add one more activity in this station, then it will be more than 20. So here my dear, this will be the first station. This will be the first station. This will be the first station. Am I clear? Now add G, F and B. 7 plus 4, that is your, I think 7 plus 4, that is 11. 11 plus 5, that is your 16. 16 plus 10, that is 26. So this is your second station. Right? Now again see here, 10 plus 5, 15. 15 plus 5, 10, that is what? 25. So this is the second station. 10 plus 6, 16. 16 plus 7, more than 20. So this is your next station. That is the third station. 7 plus 10, 17. 17 plus 6, more than 20. So this is your fourth station. Okay. 9 plus 6 plus 9, your 15. So this is your fifth station. So how many stations are there? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Did I miss something? Please see, did I miss something? A, D, C, G, F, B IE, yes. IE, yes. JH, yes. KL, yes. MN. How many substation? One. Oh my God. Yes, 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 yes. So 1, 2, 3, 4, 5 and 6. So how many stations are there? 6 stations are there. Right. How many stations are there? 6 stations are there. My dear, find out the total work content. Total work content. Total work content. Right. Here I am going to write what is 6 plus that is 18, right? That is 18, right? And that is what? 16, right? That is what? 15, right? At the fourth one, what? 16 again. At the fifth one, 17, right? At the sixth one, that is 15. That is 15. So add these stations time. When you add these station time, my dear, it will give you total work content. That is a total, all the time of the station, and it will give you 18 plus 16 plus 15 plus 16 plus 17 plus 15. It will give you 97. It will give you 97. Okay, it will give you what? 97. Now, line efficiency. Now, you have to find line efficiency. Right? You have to find line efficiency. Line efficiency is total work content, total work content, total work content divide by total work content divide by number of station into number of station. Okay, please see here, number of station into cycle time, yes or no? Now if you are talking about the efficiency, then multiply with 100. So total work content is what? 97. Number of station is what? 6. Cycle time is what? 20 into what? 100. Am I clear? Arey Baba, tell me, am I clear or not? So here you are going to find the cycle efficiency, line efficiency 90, 120. So here it will become 80.83%. 80.83%. Am I clear? Now balance delay. Find out the balance. Find out the balance delay. It will be 1 minus 0 point or 100 minus 80.83, right? In the percentage, how much it will become? 19.16. 19.16 percentage. Okay, 19.16 percentage will be come. Tell me yes or no. Are you getting this point? Is that clear? Tell me, is that clear or not? Is that clear? Is that clear? Is that clear? Is that clear? Tell me, beta, is that clear? Any doubt? Any doubt? Is that clear? Any doubt? Any doubt? Yes, my dear, any doubt? Anybody has any doubt, you can ask. Okay, can I give you a question? Can I give you another question of different the previous chapter which we have learned? Can I give you the question from inventory? One question. Will you solve? Okay. Please solve this question. This question is from inventory. Okay, this question is from what? Inventory control. But in the yesterday class, we have not the sufficient time to solve this. So, can you please solve this? This is the last question of our session. So, can you please solve this? Okay, try at least here. At least try this question. At least attempt this question. At least attempt this question. Okay, I will solve. What this question says? This question says a particular item has demand. This is the demand, right? This is the demand of what? 9,000 unit per year, right? 9,000 unit per year. Okay. The cost of one procurement is, that is the ordering cost. C naught is the ordering cost, rupees 100. Okay, and the holding cost per unit, and the holding cost per unit is what? Rupees 2.4 unit per year, right? The replacement is instantaneous. The cost of shortage is given as, here shortage is allowed, my dear. Here shortage is allowed. So shortage is allowed and it is given to what? 2.4 rupees. Oh sorry, the shortage is given and here the shortage is what? Shortage is 5 rupees per unit. Shortage is rupees 5 per unit per year. Rupees 5 per unit per year. Now the economic lot size. Economic lot size will be, okay, under the shortage condition, you have to find the economic lot size. Economic lot size you have to find. Yes, can you find this? Can you find this? Economic lot size? Yes, can you find this economic lot size? My dear, when there is a shortage, so what is the formula? Economic lot size formula for the shortage condition, that is what? Root 2 C naught D by what? CH. Yes or no? Yes or no, tell me. And CH plus CS divide by what? CS. Yes or no? So you have to just put the value. You have to just put the value. So what are the value? The value is very simple. The value are very simple. 2 into C naught, that is what? 100 into D, that is what? 9,000 divide by 9,000 divide by what? Divide by CH. CH is what? 2.4. CH is what? 2.4 plus CS is what? 5 divide by what? CS, that is 5. So will you calculate this? It will become 1053 units. 1053 units per order. It will become 1053 units per order. Now you have to find the minimum cost. Okay, the number of order per year. What will be the number of order? My dear, the number of order. This is what? This is the first part. Now the second part will be what? Number of order. That is what? That is the N naught. Number of order. That is what? N naught. So the number of order will be what? 9000 divide by 1053. 1053. That is D by Q, na? That is D by Q. How much it will become? 8.55. So 8.55 order per year. Now this is the second part. Oh sorry, this is the second part. Now third part, the time between the order. How can you find out the time between the order? Third part, time between the order. Let's say T naught. So it will be what? 1 by N naught. It will be what? 1 by 8.55 into what? 12 order per year, right? Oh sorry, sorry, it will be time now. So I have multiplied by 12, so it will be give the time in month. Okay, time in month. So 1.44 month will become 1.4 month will become, right, the time between order. Total cost per year, if the cost of one procurement is what? 1. So my dear, the cost is purchasing price into demand plus root of 2 C naught D into CH into root of what? CS, root of CS divide by CH plus CS, right? CH plus CS. Am I clear? Am I clear? Yes or no? So here purchasing price is what? Purchasing price is what? 1 into demand is what? 9000 plus root of what? 2. Ordering cost is what? 100. Demand is what? 9000 into CH is what? CH is what? 2.4, right? 2.4. Okay, into root of what? CS is what? 5. CS is what? 5. So here 5 plus what? 2.4. So you will get the total cost, yes or no? So what will be the total cost? It will become 10,710 rupees. 10,710. Okay, per year. Am I clear? Are Baba, tell me, am I clear? Are Baba, tell me, am I clear or not? Is the point is clear? Is the point is clear? Yes. Yes. Okay. So tomorrow we are going to meet with another session, with another topic, right? With another session and another topic. So thank you very much for watching this session. Okay. Bye. Have a nice day. And please keep revising the thing, right? Please keep revising the thing. Thank you.